In this video, we are going to go over Chapter 10. Chapter 10 is continuing on the hypothesis test, but instead of dealing with one set of sample that we did in Chapter 9, now we are going to move on to two sets of sample. So instead of comparing the mean value with a particular number, like remember in Chapter 9 we had mean cell phone radiation level less than 1 watt per kilogram. We are comparing the mean value with a particular value. Now in Chapter 10, instead of comparing to a number, we're going to compare within two groups, Group 1 versus Group 2. So that's the only thing that's different in Chapter 10. So we'll still play around with all those hypothesis tests, t-test, z-test, and then the proportion test. But everything now will be, instead of t-test, we have a two sample t-test. Instead of z-test, we have two sample z-test. One prop z-test moved to two prop z-test because we have two sets of samples. So let's begin with couple definitions and then get to notation and then jump with the examples. Definition: two samples are, we call it independent. If the sample values from one population are not related to or somehow naturally paired or matched with sample values from the other population. So basically, for one set of sample has nothing to do with the second sample. Okay, so we'll treat it as a two different set of data. The notation. Now in the past, we had like X bar equal to normal distribution, or X bar dealing with T distribution, or something like the proportion dealing with normal. Now, instead of these one variable, since we are dealing with two population, we are going to have X1, the mean from the first sample, with second sample. So the notation, the variable is two variable. Now, let's recall, and the structure follows exactly the same. In Chapter 9, and you can open up Chapter 9, when we deal with mean, with sigma unknown, it was a t distribution, so we used the t-test. So same thing. If we are dealing with mean, with unknown standard deviation, so we don't know the population standard deviation, then this will be equal to t distribution. So we'll use the t-test. Instead of t-test, because it was a one sample, we will use two sample t-test. So the notation looks like this. This will be equivalent to t distribution. We put the mean value, the difference between the two population mean, and standard deviation is calculated as, instead of S divided by n, since we have two, sample standard deviation from the first group square n1 plus S2 squared n2. So the calculation is a little bit messy just because we have a two different set, but think of it as like an averaging, right? You're summing up and then divide by the number. So again, this will be t distribution, student t distribution, because standard deviation is unknown. We'll move on to the case where standard deviation is known, then it will be the normal distribution. On calculator, the function is called two sample t-test. Okay, instead of t-test, we go to two sample t-test. So from the calculator, just like we did it in Chapter 9, the calculator will give you these two values, the test statistic t-value, and then also the p-value. So you can manually calculate this here, but the number is messy. There's a fraction over fraction, and then within the fraction, look at the denominator, there's another fraction. So instead of calculating manually, use the two sample t-test, and then you'll get the t-value and then p-value. We'll use a p-value to compare with the alpha to make a decision and then also write a concluding statement. Okay. Degree of freedom, we talked about the distribution, the T distribution. Normally when I first introduced T distribution, degree of freedom was at n-1. Degree of freedom is calculated as this formula here. It's not simply n-1 because two sample might have a different sample size. So the formula is a little bit messy. Okay. But the calculator will also give you this. So don't worry about calculating all this using the formula. In fact, I will not be using the formula. I'll use the calculator to calculate these values. Okay, let's move on. Here's the first example. So let's take a look at this. A student at a four-year college claims that mean enrollment at four-year college is higher than the two-year college in the United States. Two surveys are conducted. Of the 35 two-year colleges surveyed, the mean enrollment was 5,060 with a standard deviation of 4,777. Of the 35 four-year colleges surveyed, the mean enrollment was 5,466 with a standard deviation 8,191. Conduct the hypothesis test at the 5% level. First, let's highlight our testing claim. Remember, testing claim will help us write alternative hypothesis. That's the very first step of the hypothesis test. Here's what they claim. Claim that mean, so that's our parameter, mean enrollment at four-year colleges is higher than at two-year colleges in the United States. And you can also see that there's two sets of data. For two-year college, 35, that's your sample size, mean enrollment and standard deviation, that's one of them. And here's the second group, the four-year data value. So in the past, in chapter 9, it was only one set of data. Now you're dealing with two. That's the only difference between chapter 9 and 10. So the next exam will be just chapter 9 and 10. You have to decide whether you're dealing with one set or the two sets. Okay. All right, so let's start labeling things. So I'll use red one, color coded. So group 1 is a two-year college, and then write down all the information. And then group 2 will be the blue color, and this will be a four-year college data. Okay, so first one, you see there are 35 sample data. So for the first group, the two-year college, and I'm gonna use this subscript two-year, just because if I just use n equal to 35, this one, they happen to have a same size sample, but when we just say n equal 35, you don't know which n we are talking about. It could be two-year college, four-year college. So I like to use a subscript to label the data, where the data comes. 35. The mean enrollment. Now here, be careful. We are dealing with 35 data, so this will be, even though you have a mean and it doesn't say anything, this will be your sample mean. Same thing here. This is a very common mistake. You see the word standard deviation and then assume that this is a population standard deviation. It is not a population standard deviation because if you look at the whole sentence, we're talking about standard deviation of 4,777 of our sample size 35. So this deals with only the 35 data. So this is your sample standard deviation. Therefore, your sigma is unknown. Population standard deviation is unknown. So there's a huge difference when you see standard deviation, the word standard deviation, don't assume that that's your population unless the problem tells you that it's a population. You have to read the sentence carefully and see if that standard deviation is a sample or population. If it's a population standard deviation, it will not be a t-distribution, it will be a normal z-distribution. But this is a sample standard deviation, so therefore this is a t-distribution. Okay? So we have n equal to 2 years, and then we have the mean, the sample mean of the 2-year college is given as 5,068, and then sample standard deviation is 4,777. Now let's fill in some information for group 2. Sample size is same, 35. Mean enrollment, so sample mean, so the out of 35 data of the 4-year was 5,466, and then S for 4-year will be 8,191. All right, let's start with the step 1. Step 1 is null and alternative hypothesis. We have the null and then alternative hypothesis. Remember what I highlighted, that's your alternative hypothesis testing claim. What does it tell you? Literally translate. 4-year college is higher than the 2-year college. You're comparing between the two. What's our parameter? Mean, right? We have a mean of 4-year college higher than 2 years. So you have mu of 2-year, mu of 4-year, mean of 4 years, so greater than. So your null will be, so 2 year is less than 4 year. So the null will be opposite. 2 year will be greater than or equal to than 4 year. Okay, so let's select. So we have the null will be this one here. 2 year greater than or equal to 4 year. Alternative will be less than. Okay. What is in word state your random variable x bar 2 years subtract x bar 4 year, which is your random variable from the notation here. This is just basically, you just literally translate that. You see the word subtraction, so that's a representing difference, different value of what? So x2 take away x4, that will be representing difference between mean enrollment of 2-year college to 4-year college. Right? Okay. State the distribution. So this will be your t distribution. Why? Because sigma is unknown. T distribution, since sigma is unknown. So for t distribution, we have to calculate the degree of freedom. So let's calculate it. Do not use this formula because it gets messy. So I'm going to use 2-sample t-test, in fact, to calculate D, E, and F. I'll get the degree of freedom value, and then also test the statistic value, t value, and then p value. Okay. So let's pull out the calculator. Okay, so here's our calculator. It's called 2-sample t-test. Let me. Two-sample t-test. All right. So it's on the same part. So stat test 2-sample t-test. No longer t-test. It will, because it's a 1-sample. Now we are dealing with 2-sample. So 2-sample t-test. Enter, and it's gonna ask you to put some information. We are given not the list of data value, but statistical value. So change input as a statistic, and you see all these number. So 1 is group 1, 2 is group 2. So do not mix up these number when you're entering the values. So your group 1 was 2-year college. So X bar, that was 5,006. That was 5068. Okay. And then sample standard deviation was 4,777. And then N1 was 35 students. Now moving on to group 2, X bar was 5,466. And then S will be 8191. Same sample size, 35. We had a mean. Your alternative hypothesis was group 1 was less than group 2. So that's good. And then this is the first term that you see that pool. Pool means, I'll talk about it when we are going to be using it. This will be at the end of the chapter when we start matching up. So pool basically means it's like we deal with 2 sets of data, but you are kind of averaging it by making into one sample. We don't want to do that. We want to take it separately, comparing between the 2 sets. So we'll keep it as a known. Okay, and then we'll calculate. So there you go. So you have all these information. These first 3 lines will be the answer for D, E, and F. D, the degree of freedom right there, 54.73. T value is a negative 0.2483. And then P value is 0.4024. Okay? So let's put that. So T, they want you to write it with this notation, T with the underscore of degree of freedom value. So T, 54.73. Test statistic T value was a negative 0.248, rounding to the 3 decimal place. Be careful here, instruction, Z distribution, it's asking you to round it to 2. T was a 3, so I rounded to the 3. And then P value is rounding to the 4 decimal place, 0.4024. Notice the T value is a negative. Why is it negative? Look at your alternative hypothesis, it's a less than. So this is a left tail test. So you're going to have a left tail test. So all these critical value and then P value is on the left side. Here's your T equals 0. So that's why you're having a negative value. These are the things that you can check to see, oh, does it make sense that I get a negative value? Yes, because you have a left tail test. Let's keep going. Oh, so that kind of answers question G. It's a left tail with a 0.4, so it's almost halfway. So the correct one will be this one over here. Alpha value was, we want it at a 5% level, so 0.05. So let's make a decision. So that's step 5 of your hypothesis test. So we have P value from the previous page, 0.4024. Alpha value was 0.05. We have a P value greater than alpha. If you do not recall, you can open up chapter 9 notes. When we have P value greater than alpha, decision is do not reject the null. So therefore, there is not sufficient evidence to conclude the claim. So we had P value greater than alpha. So again, do not reject the null. Do not reject the null. Because p-value was greater than alpha, we do not reject the null hypothesis. So the conclusion will be there is not sufficient evidence to show the mean enrollment at 4-year college is higher than at 2-year college in the United States. Part I, explain how you determine which distribution is used. This was discussed earlier. Well, it was a t-distribution. We know it wasn't standard normal, so we eliminate the two options. The t-distribution because population standard deviation was unknown. Okay? Population standard deviation is known, then you use normal z distribution. Just like we did it in chapter 9. Mean with sigma not known, t. Mean with sigma known, z. And then be careful, standard deviation, whenever you see the word standard deviation, this one had a standard deviation word, but this was a sample standard deviation. You have to know population standard deviation to decide t or z distribution. Okay? So let's move on to the second part. This time, we are going to do the same thing, mean, but with standard deviation known. Population standard deviation is known. The following example illustrates hypothesis test for independent mean with known population standard deviation. The sampling distribution, so therefore, is normal because population standard deviation is given. So your notation will be normal. This first part represents our mean value. The second part represents the standard deviation. Notice that I'm not using S anymore because population standard is given, so you use a sigma value. Test statistic is now z-score because it's a normal z. Again, the formula is messy, but we are not going to be using the formula. We'll use a calculator and it will give you the z-score and also the p-value. On calculator, the name for the calculator is very similar to what we did. It's a z-test, but instead of regular z-test, you're going to use two-sample z-test. Why two-sample z-test? Because we are dealing with two sets of data. Okay, so this time, mean parameter is mean, and then population standard deviation is known. Then you use two-sample z-test. So here's the exercise. Let's take a look at this one. Parents of teenage boys often complain that auto insurance costs more on average for teenage boys than teenage girls. A group of concerned parents examined a random sample of insurance bills. The mean annual cost for 36 teenage boys was $680. For 23 teenage girls, it was $555. From the past year, it was known that population standard deviation for each group is 180. Determine whether or not you believe that mean cost for the auto insurance for the teenage boys is greater than the teenage girls. Conduct the hypothesis at 5% level. So here is our testing claim. We want to determine whether the mean cost for insurance of teenage boys is greater than teenage girls. We are comparing again group to group, boys to girls. So this is two sample. So for the boys, let me highlight all the information for the boys. The mean annual cost for teenage boys was $680. And then for teenage girls, it was $555. And you see that here, they use word population standard deviation. So this is a sigma value. For group 1 and 2, they're both all same. 180 for boys and 180 for the girls. So you see the word population. In the earlier example, you didn't see the population. You just saw the standard deviation. So that was for the sample. Okay? You'll see the word clearly saying population. So this is a z distribution. Okay? Z distribution. Okay? That's how you distinguish between T distribution and Z distribution. Sigma known, sigma not known. Population standard deviation given or population standard deviation not given. So let's label all the information. So group 1, I'll do boys. And then what do I know about the boys? I know the mean for the boys was a 680, and then the sample size for the boys group was 36, and population standard deviation for the boys are 180. Group 2, girls, right? X bar girls, we have 555. Sample size for the girls, 23 teenage girls, and then it's same for the girl. The standard deviation for the girls group is 180. Okay. Step 1. Null and then alternative hypothesis. What I underline testing claim is your alternative hypothesis. So I like to begin alternative first and then make a contradicting statement to come up with the null. So we have a mean. You see the word mean. So our parameter is mean. Boys compare with the girl. We have a greater than, right? They're claiming that greater than. So you have the null as boys less than or equal to the girl. Step 2, alpha value. What's our alpha value? Conducted at the significant 5% level, so 0.05. Step 3, this is a normal Z. I mentioned that it's a normal Z distribution because sigma is known. Okay, so the notation I'll use is this one over here. So let's calculate our mean and then standard deviation. So x1 bar, or the boys, group 1, versus group 2, the girl, is a normal distribution. Let's plug it in. Mu1, mu2 is the mu1 minus mu2. So what do I know about the population? The mean value. Let's keep reading. A group of concerned parents examined the random sample of insurance bill. The mean 680, 555. From the past, the population standard deviation. So this is a standard normal Z distribution. So we have each population as a 0. Remember, this is a population mean. Standard normal distribution has a mean 0, right? So we have 0, take away 0, which is 0. And then we have standard deviation. We know our standard deviation is 180 for each. So 180 square. N1 is 36. N2 is 23. Okay, so let's simplify a little bit better. Boys, X bar girl. Normal 0 take away 0 is a 0. Standard normal distribution again is a 0, mean 0. And the standard deviation will be, if you put this one on the calculator, decimal value, I get 48.05. Okay. Step 4, let's calculate the z-score and p-value. Okay. So step 4 is, again, where am I getting this steps? Here, chapter 9. We still follow the same structure of our 6-step procedure, okay, to conduct the hypothesis test. So this one, what tail is this? This is dealing with right tail test because you have a greater than, right? Right tail test. So this is a right tail test. And we use two sample z-test. So we have the following right tail test. Let's calculate the z value and then p value. So pull out the calculator. Stats test, two sample z test because normal z distribution. We have group n, all the ones are the boys and then 2 is the girls. So let's enter this. They are 180 given on the problem. 180. The boys mean value was 680. Size 36. The group 2 was a girls, so we have 555. And then N2 is 23. 23. And then it was a right tail test, so greater than. Okay. Then let's keep going down. Again, you can use calculate or draw. I show you that it's the same thing. You can get both. This time I'll do the draw function. You see the right tail here, tiny bit over here. Okay. And then z value 2.60, rounding to the 2 decimal place. P value 0.0046. Z value 2.60, P value 0.0046. So step 5, P value compare with alpha 0.0046, compare with alpha 0.05. We have a P value less than alpha this time. You have a P value less than alpha. We are going to reject the null. So there is sufficient evidence. Okay. Step 6. Write a conclusion. There is sufficient evidence to show that the average cost for auto insurance for teenage boys is greater than that for teenage girls. Okay, so that's it. So again, the concept is exactly the same. We follow through 6 steps. We still go through Z or T distribution using the test functions on the calculator, and then write down the conclusion. The only thing that's different from 9 to 10 is 9 we deal with 1 set of sample, chapter 10 we deal with 2 sample. So let's move on to our last proportion, last parameter, which is proportion, this one here. Proportion will be going back to the normal Z distribution. Okay, so comparing two independent population proportion. Comparing two proportion, like comparing two mean, is common. If two estimated proportions are different, it may be due to difference in the population or it may be due to a chance. Hypothesis test can help determine if the difference estimated proportion reflect the difference in the population proportion. So again, you have the notation, the proportion is dealing with the normal distribution. And here our mean is 0 because standard normal distribution, the mean is 0. And then your standard deviation is calculated slightly different. Now P of C, you see a new notation called P of C. This is called a pooled proportion. Remember earlier on the calculator I said do not worry about the pool, just say no. So I want to mention what's the difference between pooled and unpooled and when to use it. In previous section, since the population variance might be unequal, we perform unpooled t-test. So two sample t-test, we use pool as a no, right? Unlike means, the variance of proportion is calculating using the proportion when we conduct, oh wait, I think I skipped this one. If we know two population variance were equal, we could perform a pool t-test. Unlike means, the variance of proportion is calculated using the proportion. When we conduct the hypothesis test for the two population proportion, we assume that population proportions are equal. This means that we are assuming the variance are equal, which means we pool. Pooling will give us better estimate. So the wording sounds a little bit confusing in the description. So basically for the mean, we are not going to use the pool. For the population proportion, we'll use the pool, okay? And then pooled proportion is calculated as this one here. Okay? So let's take a look at the next example. Oh, by the way, we do have a calculator to calculate the z-score and p-value. So on calculator, and you guys can kind of get the idea of the name. Now, 2-prop z-test. In the past, it was a 1-prop z-test. Now you're dealing with 2-prop z-test. Okay. All right, so let's take a look at the following example. Two types of medications for hives are being tested to determine if there is a difference in the proportion of adult patient reaction. 20 out of a random sample of 200 adults given medicine A still had hive 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hive 30 minutes after taking the medication. Test at a 1% level of significance. Let's highlight a couple things. First one, what are we testing? We want to claim or test out the claim that test to claim determine if the difference in the proportion of adult patients' reaction. Okay. We have two groups, medication A. So these are my information for medication A. And then this one over here is medication B data value. 12 out of another random sample of 200 adults given medication B. And then we are going to use a 1% level of significance. Okay, so let's write down a couple things. Group 1, medication A. What do we know? We have 20 out of random samples, so sample size of medication A is 200, and then X, not X bar, remember proportion is a percentage, X over N, right? Medication A, and you don't see the word mean, so we are not dealing with the mean anymore. That's 20, so your P hat will be 20 out of 200. Group 2 is medication B. And then you have N equal to medication B, which is sample size still 200. Now this time your X value is 12 out of 200. So P hat of medication B will be 12 out of 20. Okay. All right, so we have our step 1 of hypothesis test is decide null and alternative hypothesis. So orange, what I highlighted in orange is your alternative hypothesis. We want to see if there's a difference in the proportion. So you see the word difference. I don't see the word greater than or less than. Now you're looking at the difference or no difference. So going back to chapter 9, there was 3 scenarios, right, for the alternative hypothesis. Looking at the difference will be basically this one here, right? This was an example. Mean GPA is different from 2.0, so we use not equal to and then equal to. So we'll use that case too. We are looking at the difference or no difference. So PA, medication A, not equal to PB, so null will be PA equal to PB. Step 2, alpha value, we want to do 1% level of significance, so that's 0.01. Step 3, this is a normal Z distribution because this deals with the proportion. So the notation P bar A, difference between P bar A and P bar B is normal with the 0 mean value. And here, take a look at this. For the standard deviation is calculated as this one. So let's calculate the pool proportion value and then substitute it here. So on the side, pool proportion is XA plus XB over NA plus NB. So XA, so 20 plus 12. Here XA, XB. All over your NA and B. NA and B. So 200 plus 200. So this will be equal to 32 out of 400. So put it over here. P of C, that's your first one. So that's 32 out of 400 times 1 minus piece of C, 32 divided by 400. Okay, and then 1 over N of A, 200, plus N of B, 200. That's my notation. And then I'm going to use the calculator to change your decimal value, rounding to the 4 decimal place. So P bar A minus P bar B, normal, 0.0271. Okay, that's what I have for my standard deviation. Let's do step 4. Step 4 is determining the tail. This is your alternative hypothesis is not equal to, so it's a two-tail test. So you're gonna see the double-sided shaded in. Step 4, two-tail test. Here. And then let's calculate the z-score p-value so we can get we can compare the p-value with the alpha value. Okay. All right. So the name is 2-prop z-test. Stats test 2-prop z-test. So x1 was 20 out of 200. x2, 12 out of 200. We have not equal to the double tail, and you're gonna see the picture. You can do calculate or draw, either one is okay. So you see the double tail with z-score 1.4744, p-value 0.1404. So z-value 1.4744, p-value 0.1404. Step 5, compare the p-value with alpha to make a decision. P-value 0.1404, alpha value 0.01. We have a p-value greater than alpha. P-value greater than alpha, we do not reject the null, so there is not sufficient evidence. Do not reject the null. So step 6, there is not sufficient evidence. Claim that there is a difference in the proportion of adult patient reaction. Okay? All right. So we went through everything, mean with sigma unknown, mean with sigma known, and then we also went over the population proportion, okay? Now we have one more section to cover, so let's go on to 10.4. Now 10.4 deals with still two data, but we have dependent sample. We had an independent in the past. Independent sample. Now we look at dependent. Two samples are dependent, or we call it dependent, or we call it matched pairs. If the sample values are somehow matched, where the matching is based on some inherent relationship, such as before and after data, husband-wife data, where matching is based on some meaningful relationship. So what does that mean? 10.123, we use the data as a separate things, right? There wasn't really matching thing going on. It was two different groups, boys and girls. 2-year college and then 4-year college. So these data were not dependent on each other. It was independent. One data do not affect the second data. However, in 10.4, we are going to actually start with the two sample and then match those sample values side to side, and then look at their difference data value and then treat only one data value. So you see the word matching. So you match up and then make it into one group. So that's the difference. Okay, so you're basically dealing with what we start with the two sample. Now you're dealing with one sample. In a hypothesis test for matched or pair sample, subjects are matched in pairs and difference are calculated. The difference are the data. So again, we are dealing with the difference data, not the separate data from the groups. The population mean for the difference mu of D, so you see the subscript D. I'm not labeling group 1 and 2. I'm only dealing with one set of data now, the difference data. It's then tested using a t-test. Why t-test? Because we are dealing with the mean and then sigma is not known. With n-1 degree of freedom, where n is number of differences. So it's not a sample data, it's the difference data, subtract 1. The test statistic t-score is given as the following, but we are using the t-test on the calculator to get the t-score and then p-value. Okay. So on calc, we'll do t-test. Notice I'm not using two sample t-test. We are dealing with one set, the difference data, so we are using just single t-test. So let's take a look at the next example and determine how it's different. Are presidents taller than their main campaign opponent? Data set 12 in Appendix D lists heights of US president and their main opponents in the presidential campaign. We will use only the sample data included in Table 9-1. We use only small random selection of available data so that we can better illustrate the method of hypothesis testing. Use the sample data in Table 9-1 with a 0.05 significant level to test the claim that, so here's the testing claim, for the population of heights of president and their main opponents, the difference have mean greater than 0 centimeter. So the president tend to be taller than their opponents. So let's highlight what we were testing. Claim that for the population of heights of president and the main component, the difference have the mean greater than 0. So first, how do you determine if this is matched pair or not? You see the word mean. So here's the key word. Okay. And also you see the word difference. So this is not really looking at the mean compared with the second group. You're really looking at the difference of president's height, subtract opponent, and then look at the mean of their difference value. So here's what we are going to do. We are going to create another row, calculate the difference value. In the past, we had, here's group 1 data, and then here's group 2. Now, we are not going to do that. We are going to now calculate the difference between group 1 and 2, and then look at their mean of the difference. So 189, so we want president, take away the opponent. So 189, take away 170. The difference value is 19. 173, take away 183, that will be a negative value. It's okay if you have a negative. That means the president is shorter. 183, take away 175 will give us 8. 180, take away 180 is a 0. And then the next president and then opponent was a 179. Take away 178, it's 1. So your data now deals with this here. Okay. Okay, so we'll deal with these numbers. So let's do a hypothesis test. Step 1. Step 2. Step 1, null and alternative hypothesis. Okay. Now, look at what I underlined or highlighted in orange. Mean of the difference greater than 0 centimeter. That's your alternative hypothesis. Mean of the difference greater than 0 centimeter. Okay. So your alternate null hypothesis will be mean less than or equal to 0. Notice that I'm not comparing president to opponent. You see that in the testing claim, I want to look at the difference of the mean, not president taller than main opponent, right? So you have to be careful when you read the questions. Step 2. Alpha value will be 0.05. Okay. Step 3. This is t distribution. We're dealing with mean. Population standard deviation is not known, so this is a t distribution. But we will be using t-test, not two sample t-test, because we are looking at just one set of data now. Step 4, we have alternative greater than, so this will be the right tail test. Let's calculate the t value and then p value. And then the degree of freedom is calculated as degree of freedom is n-1, where n is the number of difference. 1, 2, 3, 4, 5. There are 5 data of difference value. So 5 take away 1, which is 4. So you have t of degree of freedom 4. Okay. So let's pull out the calculator, get our t and then p value. T-test. Enter. We are given the list of data this time, so we hit data, and then mean was a 0, right? And then we need to put our data value, those 5 difference value in L1. So let's do that. Stat, edit, L1, you can erase if you have the previous data. And then do not put your president and then main opponent data. Remember, we are dealing with the difference data value, so only enter your difference data value. So first one was a 19, second one was a -12. Use this negative here. Do not use this negative. That's a subtraction operation, so you'll get an error. So this is a number negative. -12. And then 8, 0, 1. Okay, so again, stat, test, t-test. We put it at 1, frequency 1. We had a greater than 0, so greater than right tail. Okay, and then calculate or draw, up to you. I like having the visuals, so I'll go ahead and then use the draw option. Here's your t value, here's your p value. Okay. So from the calculator, we have a t value, 0.6283, p-value 0.2819. So step 5, let's compare p-value with the alpha value. P-value alpha, p.2819, alpha value 0.05. We have a p-value greater than alpha, so therefore we fail to reject the null. Okay. We failed to reject the null, so step 6. We failed to reject the null, so there is not sufficient evidence. to claim that the difference of height of president and their main opponent have a mean greater than 0 centimeter. Okay. All right. That's it for chapter 10. I'll see you in chapter 11 video.